I'm going to discuss today one very good problem from functional equations. Okay, functional equations. The question says if fx plus fy is equal to fx plus y divided by 1 minus xy for all x comma y belonging to capital R, and xy is not equal to 1. Also, limit x tending 0 fx upon x is equal to 2, then find the values of f bracket root 3 and f dashed bracket minus 2. Alright, the solution goes like this. Let us start from the equation which is given fx plus fy is equal to fx plus y divided by 1 minus xy. If we put y is equal to minus x, then what we get? Fx plus f bracket minus x is equal to f x minus x divided by 1 plus x square. This remains as it is, means fx plus f bracket minus x, and in the right hand side we are left with f0. So let it be equation, this one is equation number 1, this one is equation number 2. So what we are getting over here is f0. So that f0, let us try to get from the equation number 1, means from this one. So what we do now, let x is equal to y is equal to 0. Then equation 1 gives f0 plus f0 is equal to f0 plus 0 divided by 1 minus 0, which is equal to f0. So finally, solving this particular equation, we will be getting 2f0 minus f0 is equal to 0, which is nothing but f0 is equal to 0. Alright, so this is one of the important result which we have got, and this result we can use over here in the equation number 2, so that we are left with fx plus f minus x is equal to f0 is equal to 0. So finally what we are getting, fx is equal to minus of f bracket minus x. This minus, if we bring this side, we will be getting minus of fx is equal to f bracket minus x. Let it be equation number 3. Alright, now let us use the basic concept related with the differentiation of the function. Means I am writing f dash x is equal to limit h tending 0 fx plus h minus fx whole divided by h. I hope you remember this particular concept which we have learnt in the class 11. Now this minus fx from here do you find can be written equal to f bracket minus x, means this will become limit h tending 0, limit h tending 0. Okay, let us modify this thing. This maybe you will get confused. So let us first modify it. Limit h tending 0, f bracket x plus h plus minus f bracket x whole divided by h. So are you finding this whole quantity from here can be written equal to f bracket minus h, so that it becomes limit h tending 0 f bracket x plus h plus f bracket minus x whole divided by h. I hope it is clear to all of you. Now focus the original equation, that is I am talking about this one, and imagine in place of fx you have over here fx plus h, and in place of fy you have f bracket minus x. Then as okay, let me just write the equation number 1. From 1 we had fx plus fy is equal to fx plus y divided by 1 minus xy. So what I am going to do is, in place of this x you have x plus h, in place of this y you have minus x. So let us put in place of this, means f x plus h plus f bracket minus x can be written equal to f, in place of x we can write x plus h, and in place of y we can write minus x, and in the denominator we are left with 1 minus, in place of x this one x plus h, and in place of y minus x, so that this becomes into x. I hope you all have understood till this point. So what we are getting over here is equal to f. These x are getting cancelled and we are left with h divided by 1 plus x plus h. Okay, so what we are getting is, we had started from what? We had f dash x is equal to this one. F dash x was equal to this, and this whole thing is equal to this. So can we write f dash x is equal to, so what I am writing is f dash x is equal to, in place of this whole quantity, this one, with limit h tending 0, limit h tending 0, and f h divided by 1 plus x plus h, and in the denominator we had h, so that h I am writing over here. Alright, till this point I hope you have understood, all of you. Now coming back to this particular result which was given in the question, that is this. We had limit x tending 0, fx divided by x is equal to 2. Using that, using this we can write using what we had actually is this. So let me just write this result below this one. Means we have limit extending 0 fx by x is equal to 2. I hope this was the result given. Yeah, limit extending 0 fx divided by x is equal to 2. So are you finding a similarity between this particular result, that is this one, to this? Only thing is h divided by, means this particular part, this portion, h divided by 1 plus x into x plus h is missing in the denominator. So what, let us multiply this whole quantity in the denominator and the same quantity in the numerator. So what we get is f dash x is equal to limit h tending 0, and we can write f h divided by 1 plus x plus h whole divided by h divided by 1 plus x plus h, and this h can be written over here, and in order to compensate this we have written on our own. So let us multiply the same quantity in the numerator over here. H divided by 1 plus x bracket x plus h. I hope you all have understood what I have done. So do you find this whole thing, I am talking about this one, using this particular formula which is given in the question, alright? Can we write this whole quantity as 2? So that we are getting what? 2, and then let us we take the limit h tending 0 in this whole thing, and also we find this h and this h can be cancelled, and when this h tends to 0, then this whole thing will become into 1 divided by 1 plus x into x, that is 1 plus x square, and this was your f dash x. Alright, so we are almost near the answer. Okay, we had to find out the value of f dash minus 2. So here only we can find out f dash minus 2 can be written 2 into 1 divided by 1 plus minus 2 whole square, and this is nothing but 2 divided by 4 plus 1, that is 5. So this is your answer for the f dash minus 2, that is 2 divided by 5. Now in order to get the value of f root 3, we in place of this f dash x we have to have fx. So in order to get the fx from this one, let us we integrate both sides, this as well as this. So in f dash x is equal to 2 divided by 1 plus x square, integrating both sides. We get f dash x is equal to 2 integral of 1 plus x square dx. This f dash x integration will give you fx, and in the right hand side it will be tan inverse of x plus c, a constant of integration. where C is the constant of integration. Okay, so what we have got is fx is equal to 2 tan inverse x plus c. Now we are left to find out the value of this constant c, and try to recall earlier we have got the value of f0 as 0. f0 was equal to 0. Somewhere in the beginning we have calculated this f0 is equal to 0. So what we do is, let us put x is equal to 0, then it will become f0 is equal to 2 tan inverse of 0 plus c, and tan inverse 0 is nothing but 0, and this one is also 0. So finally c is coming as 0. So what we get is fx is equal to 2 tan inverse of x plus 0. So fx is equal to 2 tan inverse of x. Now the problem is very easy. In place of x we have to put root 3, because we have to find out f root 3, and that is equal to 2 tan inverse of root 3, and tan inverse of root 3 is nothing but I think pi by 3. So 2 into pi by 3, and finally it is 2 pi by 3 is the answer. So one answer is this, and another answer we had 2 by 5, this one. Okay, thank you.